Now the topic is electric double layer. This will comes under the electrical properties of colloidal dispersion. So how the electric double layer is formed means see, this is the surface of particle. This is the surface of particle having positive charge. Means on the particle having positive charge. How many positive charges? 1, 2, 3, 6. See, 6 volts means 6 positive charges are there. So whenever the particle is present into the water generally contains ions. The water generally contains ions. The ions will move from the bulk of solution. This is, you can consider as a water. The ions will move up to the particle surface due to electrostatic attraction. Means due to the presence of ionic bond or due to the presence of electrostatic attraction, the ions present in the water, they will come and they will stick strongly. See, they stick strongly to this layer. They will stick strongly to the surface of the particle. Those are called as a counter ion. See, negative charge. This negative charge we can call as a counter ion. Counter means opposite ion. That is negative charge. Then what is the then what will be there another? See, whenever the ions present in the water, always surrounded by water molecule. This is positive charge. This is water molecule. Means there is a attraction of ion and dipole. Water is dipole. When you dissolve NaCl into the water, what will happen means there is a formation. See, there is a formation of this kind. So this is sodium. This is surrounded by water. So what kind of interaction is there? Ion dipole attraction. Attractions are there between the ion and water molecule. That is ion dipole attraction. Ion dipole attraction is there. So water itself contains ions. It is already surrounded by water. There is an ion dipole interaction is there. So the same ion. So you can consider this is the bulk of solution. In this there is a presence of what? Ion and water. This is C. This is water. This is ion. When they are present in the bulk of solution, they will move up to the surface of particle. Then they will stick, means this ion stick strongly to the positive charge. There is a formation of bonds, ionic bond, positive and negative charge, ionic bond is there. Ionic bond is formed between the positive and negative charge. Ionic bond is there. Here ion dipole attraction is there. Here ion and dipole attraction is there. So in the middle of counter ions, means in the middle of negative charge, we need to take the external layer, means this layer which is attached strictly or tightly stick to the surface of particle. We can call it as external layer or tightly bound layer. External layer or tightly bound layer, that is tightly bound to the surface of the particle, we can call as a tightly bound layer. And next one is, along with these ions, the water molecules are there. This is the water molecule. Ion dipole attraction is there now. Due to that, there is a presence of water molecule. Then the stem layer is present in the center of these ions. Then shear plane is present away from or aside to this water molecule. Near to the water molecule, what kind of plane is present means shear plane or slipping plane. Slipping, when water is there, due to the presence of water there is slipping. We can call it slipping plane or shear plane. So what will be there? When the particle, this is the particle, huh? This is the particle. So whenever this particle will move, whenever this is a particle, this white color, whenever this particle will move, there is a movement of this strictly bound ion and associated water molecule along with this, like this. They will move within the solution. They will move like this within the solution. But the diffusion layer and this is the bulk of solution means water present in the solution. This is the bulk of solution. See, this diffusion layer and bulk of solution will not move along with particle. Only what will move means stern layer. This is the stern layer. This is surface of particle. This is stern layer. This is shear plane or slipping plane due to the presence of water molecule. Then this entire thing will move like this. Like this. This entire thing will move like this. So this is completed. Next, diffusion layer. So see, diffusion layer is there. This is the diffusion layer present apart from the shear plane or slipping plane. Next one is bulk of solution. In the bulk of solution, there is a electron neutral region. Means 5 positive ions are there, 5 negative ions there. This is electron neutral region. This is somewhat negatively charged ions are there, or counter ions are there. See, this diffusion layer is present due to Y means, see, 3 charges are, see, 3 charges. Out of 6, 3 charges are neutralized here. Then still 3 charges are there. So in order to neutralize this, there is a formation of diffusion layer. So there is a formation of diffusion layer in order to neutralize this excess positive charge. There is a formation of diffusion layer. Next, electrochemical neutral region means plus 5 minus 5, neutral 0 potential here. Here something negative potential due to the this diffusion layer is formed due to the presence of, in order to neutralize the excess charge present on the surface of particle. So initially the tightly bound layer is formed due to the absorption of counter ion. Strictly means strictly or strongly to the surface of particle. We can call as a stern layer, tightly bound layer. So these ions, these ions are there now 1, 2, 3. These ions we can also call as a potential determining ion. Potential determining. See this color, I have written with this color. See potential, this negative charge we can call as a potential determining ion. See, see Y means potential determining ion. So whenever the particle will move means there is a movement of stern layer along with shear plane or slipping plane. Then whatever the charge present on the particle, there is a neutralized by this counter ion or this negative ion. So there is no further ions. This is just water molecule. This is the not ions. These are just water molecules, but these are not the ions. So this negative charge will determine the particle surface, means potential present on the particle. How this will determine the potential present on the surface means, see, 6 volts are there. At the stern layer 3 ions are there. So 3 volts. 6 minus 3 means remaining 3 are there. But what will happen now? Due to the presence of solvent, this negative ion, this anion or counter ion, see this anion cannot neutralize this positive charge. Means actually this positive charge, one unit is neutralized by this negative ion. But what will happen due to the presence of this solvent molecule? due to the presence of the solvent molecule to this anion, this will reduce how much? 0.5, only 0.5, 0.5, only 0.5 potential will reduce these ions, only will reduce the how much? Only 0.5 potential millivolt potential of this surface charge is reduced by these counter ions. Why? Actually this is positive one, this is also one. They need to neutralize 1:1 ratio. But the thing is, due to the presence of the solvent molecule, this do not neutralize, means this negative ion cannot effectively neutralize these positive charges. Why? Due to the presence of solvent. That's why 0.5 means totally 1.5 millivolt. 1.5 millivolt is present on charge present on shear plane or slipping plane. This value we can call as a zeta potential, means the total charge present on the particle can be determined by using zeta potential. So how much charge present on this molecule, on this total molecule, means why this total molecule we are calling, whenever the particle having all these three layers are moving, like particle surface, tightly bound layer and this water molecule, all these are moving. So what will be the charge of the moving particle, means 1.5 volts, sorry not volt, millivolt, 1.5 millivolt is present. Why only 1.5 means due to the presence of solvent molecules, these anions cannot effectively neutralize these positive ions. So this is the basic concept here. So next, diffusion layer is the bulk of solution. So what is the zeta potential? How we can derive this graph, means see, the surface potential of a particle is 6 volt. The surface potential of a particle is 6 volt. This is the surface. Behind the surface I have drawn the surface. This graph, this line indicating, the y line indicating, y-axis indicating surface of particle. The surface of particle. This is the surface of particle. So from this particle, the stern layer is present. The stern layer is present at a certain distance. This is the stern layer. This is stern layer is present at a certain distance. So what will be happening means there is a reduction of, there is a neutralization of 3 millivolt charge on surface of the particle. So there is a reduction. Whenever the distance increases, there is a reduction of potential or there is a reduction of charge. At the stern layer, 3 millivolt charge is there or potential is there. Still we need to move from this stern layer to shear plane. From this stern layer to shear plane, what will be just 1.5 millivolt is present due to the presence of these solvent molecules. 1.5 millivolt is present due to the presence of solvent molecule. So this point we can call as a zeta potential. Very important. Zeta potential means potential present at the shear plane. Potential present at the shear plane or slipping plane we can call as a zeta potential. I have explained why that 1.5. See, this line are indicating just a distance. See, this is the surface of particle. Stern layer is this much distance. The shear plane layer is this much distance. So upon increasing the distance, there is a reduction of potential. We have represented this like this. So this is about the electric double layer. So this entire concept we can call as a electric double layer concept. Very important. This electric double layer is very important for the stability of colloidal dispersion. The colloidal dispersion are stable due to the presence of electric double layer.